So page 215, and I feel to some degree I have a difficult job because I am talking about the Eurocodes and I have tried to make it appropriate for the situation in Ukraine, but clearly my background is in the UK. So I thought I would share with you briefly the design process from my point of view. And it may well just highlight some of my background and some of the differences perhaps between practice in the UK and here in the Ukraine. So in the UK, our steel sections would be rolled sections. It would be very unusual for us to weld a member from plate. We would always be using S355 steel. That really is the only available grade in the UK. There are many people who provide software to enable us to design composite beams, because almost all our beams will be composite with through-deck welding. Certainly in the big cities, there will be a height restriction on the overall height of buildings. So to minimise the overall height of buildings would be a very strong driver in the UK. We would also like to minimise the height of the construction depth, so from the ceiling to the carpet, because then if we save some cladding all around the building at a number of floors, then that can be a considerable saving. So to keep the ceiling to the carpet level to a minimum will be a very important driver for us in the UK. And that will lead us towards beams with openings in. Maybe the cellular beams that we saw yesterday, or the plate girders. You've heard me say this before, but in the UK we would never, ever try and repeat a concrete scheme. So 7.5 metre grids in steel, I am not interested. I would be trying to sell 7.5 by 15 metres. I would work out the wind load, but not by hand, never by hand. I would be using software that, do you understand the term purlin? So light gauge steel, 1mm thick, that supports the cladding. In the UK we call those purlins. In America I think they call them girts. But many manufacturers make software available, and the software will calculate the wind load. So I would never do that by hand. I would use somebody's software. Or you can find some free software available on steelconstruction.info. The floor solution is almost always going to be composite. If it's a multi-storey building, anything over 4 stories, it's certain to be composite. The cheapest solution for us would be a beam sitting down below the concrete slab, but that can be quite difficult because we are trying to maintain a minimum construction depth. So some of the solutions in the UK have this steel beam embedded in the concrete deck to try and minimise that overall depth. But this would, for us, be the cheapest solution. The profiled steel sheet here is acting compositely with the concrete. So we have a composite span from beam to beam, and then the beams are also working compositely. These shear connectors will be site welded, they will be site welded through the deck, and we would leave the top of the flange unpainted. We would have absolutely no props. So if we suggested in the UK to a main contractor that you could use perhaps thinner deck but prop the deck during construction, the contractor is not interested, because as soon as this deck is cast, and he wishes to be working on the lower floors, so props would not be acceptable in the UK. We would not dream of designing the slab or the member by hand. We would use some free software. So all the deck manufacturers make software available, or they provide lookup tables. We would not do it by manual calculations. And equally, the design of the concrete beam, the design of the composite beam, we would not carry that out by hand. We would use some software. This is software from the website steelconstruction.info. Perhaps it would not be very useful in the Ukraine because it only covers rolled sections rather than members fabricated from plate. So if I were practicing in the Ukraine, I would create a spreadsheet in Excel to do this for me. 70% of the structures are steel, 85% of the steel structures will be brace frames. So the simple rules for columns in simple construction we would use all the time. So there is, again, another piece of software that we would use to verify columns in the UK. In the Ukraine, before I came, I prepared a spreadsheet so that I could ensure that your worked examples would be correct. It's not difficult to create a spreadsheet that will calculate these things for you. It just takes a little bit of time. So I've got the beams, I've got the columns. I would then design the bracing system. And the bracing system, the bracing will feel load from the wind, and remember it will also feel load from the equivalent horizontal force. So I would calculate the overall wind load. I would calculate the summation of the equivalent horizontal force. And I would say, well, that's the base shear at the base of the building. And the first bracing takes the component of that base shear. So that will tell me the force in the bracing, and I would choose a hollow section. And I wouldn't dream of designing it by hand. I would use a lookup table. Here is a member, here is a length, here is a resistance, job done. So I've now got the beams, the columns and the bracing. Then I have to check alpha crit, because I want to see whether my frame is sensitive to second order effects or not. If I have done an economical design, I would expect my frame to be sensitive to second order effects. I would expect alpha crit to be 7 or 8, probably less than 10. If alpha crit is greater than 10, I think I'm giving away too much steel somewhere. If alpha crit is less than 4, I think I've made a mistake somewhere. So I would expect somewhere around 7 or 8. If I have to deal with second order effects, I think the amplification is simple. So I would amplify the lateral loads, the wind loads, plus the equivalent horizontal forces, and then I would need to recheck the bracing because the force in the bracing has increased. So I know the beams, the columns, the bracing. I have allowed for second order effects. I'm the designer. I must specify the steel subgrade. So I would be concerned about whether the steel is exposed. I know the thickness of the flange, and therefore I would use EN 1993-1-10, which we saw yesterday, the part that concerns steel subgrade, and I would specify J0, J2, whatever it demands. In the UK, there is so much competition for fire protection that I would not specify a particular product, I would not specify a particular intumescent coating or a particular board. I would say I want a performance-based specification, so a certain fire performance, and then I would allow competition to provide me the most economical solution. I would not concern myself with connections, because in my world, the connections are always nominally pinned. So I know that the fabricator is going to choose perhaps a fin plate or perhaps a flexible end plate, and I know that he will be using the rules in what we call the Green Book. which is a book of standardised connections. So I know that he's going to deliver me something which behaves as a nominal pin. So that, ladies and gentlemen, is my world. That's how we would tend to design in the UK. I know it's different in the Ukraine. Now is lunchtime, so perhaps we could recommence promptly at 2 o'clock.